Welcome everybody. There are a little shorter break between sessions that time, but this is session A08, Security Highlights, Best Practices but Using Keystores. Since David has his video on, let me know if any of you have glitches in your video or audio, and we can turn his video off in case that's causing a problem. But it hasn't so far, but I'm just letting you know if you do have glitches, put it in the chat. I'll take care of it. So anyway, have at it, David.
All right, thank you, John. I'm Dave Desautels. I've been with Informix for a long time, since 1996, and I've had various roles in the organization. So I guess I'm one of the old timers. So feel free to ask me anything as we go through this, although I'll rely on John to look at the questions that may be coming in. What this presentation is really all about is to try to clear up any confusion we have about how you use SSL or TLS, how you set up keystores, what certificates are, where you get them, what you do with them, what they look like, and any other questions about that kind of stuff. And then towards the end, I do have some of the new stuff. So with that, I'll get started here. I'm sure you've seen this slide before, so I'll move on. So we're going to talk about what certificates are, what keystores are, what you do to put certificates in the keystore, to look at certificates in the keystore, to get certificates, and then I have some examples of how to do all this stuff. So we'll see how much time we have here. So first of all, this is to clear up any confusion that comes from some of our presentations or documentation. I just want to make sure that everybody understands this stuff. TLS is a new name for SSL. At this point, they're generally used interchangeably. Something called SSL v3 got renamed to TLS 1.0. We're now up to TLS 1.3. But in any case, the names are pretty much interchangeable. GSKit uses the term key database for files that hold certificates. Informix generally uses the name keystore. For all practical purposes, these are the same things. They may be slightly different formats, but they're the same things. Okay. Previous versions of Informix used the GSKit proprietary keystore called a .keydb file. And newer versions expect a P12 file. But in order to keep working, we generally work with the KDB format keystores. A keystore is, in this terminology, is a P12 file. And this is the standard file type that's used for both GSKit and OpenSSL. OpenSSL has commands to take a bunch of certificates and turn them into a P12 file and vice versa. Also, a keystore may have a stash file that essentially contains the encrypted password, also encrypted, of course. This allows the programs to access your P12 file or your keystore without human intervention. Otherwise, you would have to be entering the password in order for us to get into the file. Informix uses keystores for other secret information, for example, encryption at rest, but this presentation is about SSL and TLS. So with that, we'll move on. Okay, first thing is the Informix server has used the IBM Global Security Kit called GSKit for IBM's FIPS implementation of SSL TLS. And Informix uses the GSKit functions for all the encryption and for SSL and TLS. This package provides a tool called GSK8 CAPI command, And the reason for the _64 is if you have a 64-bit version of GSKit, all of the stuff is, all of the commands, and there's only two, have to be suffixed with the -64 to get to what you're looking at. Okay, it's possible, and I do on my development systems, to have both 32-bit and 64-bit products installed. So you have to be sure that you're looking at the right one when you're doing something. The current product shipped with version 8.0.55.24. Okay, and you can see this if you type GSK8 ver_64. And generally speaking, now there have been some exceptions multiple years ago, but generally speaking, we will work with any newer version of GSKit. And so if there's some security issue that's got fixed in a newer version of GSKit, you can get the latest GSKit from Passport Advantage. The GSKit CAPI command guide, you can get the PDF file so that you can see exactly how to use it if there's any questions. Okay, and just another question that people ask a lot. GSKit's crypto is based on OpenSSL's libcrypto, and the APIs are very similar. But GSKit itself is not based on OpenSSL. There is no OpenSSL code that's in GSKit. Okay, moving on. If you want to use OpenSSL for the client, you no longer have to install GSKit on the client machines. And for more details on this, I'm going to refer you to session A12, where Sunil will talk about using OpenSSL for to create your SSL certificates and set up the communication for Informix. Okay, first thing is, what is a certificate? A certificate consists of a private and public key. The private key is always a protected secret and is only in the server key store. The public key is shared in multiple ways depending on how you're setting up your certificates with your users so that they can encrypt something that only you can decrypt. Okay? A certificate has an issuer name and a distinguished name. Okay, the issuer is the entity that signs the certificate, and the distinguished name consists of the stuff I have here on the screen, and you can have all or some of this. You don't have to have all of it. I will say that if you are trying to get a certificate signed by a CA that issues public certificates, has a public, their certificate, their root certificate is generally available. They will make you prove that you own the common name that you're trying to get the certificate for. I mean, this is done so that users can verify that they're talking to who they think they're talking to, and not just someone who has a open port on a server out there somewhere. Okay. A certificate also contains a start date and a stop date, and has the signature algorithm used to sign it. And a certificate may have extensions, and for example, a CA extension means that it can be used to sign other certificates. And we'll get into that more later. Okay, what a certificate isn't, right? Well, a certificate can make sure that you're connecting to the right server. There is no authentication information inside of a certificate. The SSL Handshake establishes an encryption key that's used for the session. And in the case of Informix and many other places, the authentication happens after the SSL connection has been established. You might notice that there are some tools out there that will check your SSL ports, for example, for security. And if you watch the server log, you can actually see when they try to connect to your port, but can't connect to your server because they can't authenticate. So the point here is that the SSL Connect protocol is very generic, but after you connect, you still have to authenticate. Okay, so what's a self-signed certificate? A self-signed certificate has the same issuer name as its subject name. A root certificate is a self-signed certificate that can be used for signing other certificates, and you can be your own certificate authority. I just want to be clear, although there are, some of these tools complain about self-signed certificates, there's nothing inherently insecure with a self-signed certificate, but there are issues with usability and maintainability, especially if you're doing self-signed pairs of certificates rather than trying to be your own certificate authority, because then you end up with just impossible numbers of pairs to keep up with for all of the servers and clients and everything that may try to connect to each other. Okay, so first of all, this is just a generic picture showing that at the lower right, we have a root certificate. And you can see that there's this chain of trust that goes through a certificate. And basically, if you are going to trust a owner's certificate, a certificate when you're trying to connect, you have to have in your key store all of the intermediate and root certificates required to establish that chain of trust. Now, most of the time, this is just a single root certificate. And in the case of a self-signed certificate, it's just essentially a copy of the public part of the self-signed certificate that you got from the server. So this chain can be long or short, but this is just a general picture here of a root certificate, an intermediate certificate, and finally the certificate that your server is using. Okay, so we're now going to get into the database command. So the first thing that you want to do is to deal with the key database. You can create it, you can delete it, you can change its password, or you can stash its password, right? And the command is the place here where you replace it with one of these four things I've got showing you here. And you name your for SSL in a server, you need to name your P12 database the same as your DB server name. And for what it's worth, for Connection Manager, the Connection Manager also has a name in its configuration file, and you need to name that key database the same as the name in your Connection Manager file, Connection Manager configuration file. All right. So when you go to create it, you have to specify a password. You have to decide whether you want that password put into a stash file or not. And optionally, you can populate the database, which loads a bunch of trusted CA root certificates from the people who commercially sign certificates. Now, generally, you don't need that for Informix, but if you are having your certificate signed by one of these providers, then you may want that. You can delete a key store, you can change the password on a key store, and you can stash the password on a key store. Notably, if the password is stashed, you can change the password on a key store without knowing the password, as long as you can read the stash file. Okay, this is a picture of what happens when someone tries to connect, making an SSL request, right? And the client basically issues a session request, and the server sends back the public part of the certificate that contains the server's public key. Then the client authenticates the server certificate using that chain of trust that we just talked about. If the client can't authenticate it, the connection will be broken and no connection will happen. If this happens, if everything happens okay, the client generates a random symmetric key and encrypts it with the server's public key and sends it back to the server. Okay. After the server gets it, he decrypts it with his private key, and now the client and the server know the symmetric key, and they can use that key to encrypt and decrypt data for the duration of the session. So now that we've got the key store, we need to talk about certificates. So the GSKit copy command is cert followed by one of these commands. Again, the key store name that you're trying to put it into, either the password or saying that the password is stashed, and the label for the certificate you're trying to create. Now, 20 years ago or 15 years ago, there was the concept of a default certificate. That default certificate concept has been deprecated, and all certificates require a label. And in this case, the label matches there's a parameter in your onconfig file that is the SSL keystore label that is the label of the certificate that your server is trying to use. Okay?
Dave,
Yes.
can you see the chat?
No, I cannot. Is there some way that
Okay,
I can?
I just have a question. I figured I'd try to break in here.
Absolutely.
And the name of the P12 file, also DB server alias name connection, which is SSL, or only DB server name,
Only
even if
DB
it's not
server name.
SSL type.
Only DB server name. Okay, the file may be used for any number of DB server aliases, but there's only one file, and it's opened using the DB server name.
All right.
Okay, you can have multiple aliases that use SSL. Okay, but there's only one key store, and it's the DB server name.
It's going to point back to the DB server name. Okay.
Yes. Yeah, DB server name right out of the onconfig file. Okay. So again, here's the commands for certificates. You can create, and if you create a certificate, this creates the private key for you and gives you a certificate that you can use, a self-signed certificate that you can then extract and add to a client key store if that's what you want to do. Okay, deletes the certificate. The details gives you the details of a certificate, and if we have a chance, I'll show you what that means. You can rename a certificate if you want. You can list the certificates that are in a key store. You can extract it, but when you extract it, you only get the public key, which is generally what you want for setting up a pair of endpoints using self-signed certificates. You can add that extracted certificate to a client key store. You can actually export everything in your key store to another key store, and that includes any private keys that you have in your key store. You can receive a certificate that you've requested to be signed, and you can sign a certificate if you have the right root certificate in your key store. Okay, we'll go into some details on these here. So when you create a self-signed certificate, you have to specify how many days you want the thing to be good for. You have to have an expire time. You have to have a distinguished name, which has to at least contain the common name, and it can be anything, but it has to at least contain the common name. And if you specify CA equals true, or CA true, sorry, no equals, you can create a root certificate that you can use to sign other certificates. Right? Delete is simple enough. Rename, you have an old label, you have a label name, and you can specify a new label. So essentially, this just renames or gives the certificate a new label in your key store. It doesn't do anything to the certificate itself, right? List will allow you to list all of your certificates in your key database. Now, you may have root certificates, you may have intermediate certificates, you can have server certificates. List will list what's there. And if you do details, again, if we have time, I'll show you an example of this. This will show you all of the certificate details. You just specified the label of which certificate you want to see the details of, and it will show you all the details of that certificate, including, who it was signed by, what the common name is, what the expiration dates are, everything. So hopefully we'll get to that. You can extract a certificate. Okay, this will allow you to create a ASCII or binary file that then you can add that certificate back into a different key store. Again, this is used for taking the certificate from a self-signed certificate from a server key store and adding it to a client key store. And again, export will allow you to essentially make a copy of the all of the information in the key store. Okay, we'll talk about receive a little bit more later, and this is what you do when you request a certificate to be signed by someone. After it's signed, you need to receive it back into your key store. And again, here, this is for signing a certificate. You specify the label, the file name, what the target is, the file that you're going to send back to the user that asked you to sign the certificate, and you get to specify how long the certificate is good for. Okay, so now we're getting into the certificate request. This is how you create a certificate request for someone to sign. The certificate request, the create, creates a private key in the key store and creates a file that you want to then send off to some certificate authority to sign it. You can, if you have a certificate request, it will stay in your key store until you delete it, extract it, or actually receive the signed certificate back into the key store. So for a certificate request, you can create a certificate request. Again, you can specify the file name where you're going to hold that certificate request. This is the file that you're going to send off to whatever certificate authority is going to sign your certificate. Okay. If for some reason you lost your certificate request, you can extract it to get the certificate request again out of the file. And if you want, you can recreate the certificate request if something is wrong with it. Okay, deprecated functionality. Okay, there used to be a time limit on the key database, the key store password expiration. There is no longer a expiration of your key store. Your key store will last forever. And there used to be a concept of a default certificate. Again, that has gone away. So you have to have, we used to not require you to put the SSL key store label in the onconfig file, and it would work with a default certificate. And that functionality is deprecated. Okay. All right, TLS 1.3. We've added TLS 1.3 to 1410xc6. The issue here is that there is no FIPS version of TLS 1.3 available yet in GSKit. This is essentially because FIPS certification takes approximately 18 months, and GSKit has not been able to accomplish this yet. So for now, if you want to use TLS 1.3, you set the right value in your onconfig file about which TLS versions you support. You can put 1.2, 1.3, or you can put just 1.3. And for now, you have to set this environment variable ISI GSK FIPS mode off before you start the server. And if you do that, your TLS 1.3 will work. Okay. The other issue here is that the old signature algorithm, which was the default version before GSKit 8.0.55.22, is not supported for TLS 1.3. So if you're using a version of GSKit that's older than 5522, which probably won't work with TLS 1.3 anyway, but if you're going to create a certificate, you have to specify to use the signing algorithm SHA 256 with RSA or some other suitable algorithm when you're creating or signing certificates to use with TLS 1.3. Okay, the latest versions of GSKit default to this value, so if you're, as long as you're using the latest version of GSKit, you don't have to worry about this. Okay, I will be happy to answer any other questions we have on TLS 1.3. If you specify TLS 1.2, 1.3 in your TLS versions in your onconfig file, the server will do the right thing depending on what it is that you've got specified either for your FIPS mode off or what your client is trying to do. But if you force 1.3, you have to have the FIPS mode turned off.
There is a question, Dave.
Yes.
Is it possible to define names, alternative names, or alternative names for the CSR creation using GSKit, like in OpenSSL?
CSR. Is that the, I'm not sure what CSR means in this context.
Neither am I. Anybody else know what Jan was getting at there? Certificate request.
Okay, so ask the question one more time now that I know what that means.
Yeah, okay. Is it possible to define alternative names for the certificate signing request creation using GSKit, like in OpenSSL?
I guess I'm not sure what an alternative name means in this context. I have to go look at my OpenSSL documentation, I guess. I mean, you can name the file anything you want. You can name the certificate anything you want. You can put anything you want in the common name. So I guess I'm not sure what we mean by alternative.
Alternative names using GSKit, like you can in OpenSSL.
I got that, but I'm not familiar with the certificate request in OpenSSL alternative name. I can look here, but I'm not familiar with that. But I will be happy to look into it.
Let's just go on, and if they want to try to make it clear to me, maybe
I don't know any. I mean, you can make any name, whatever name you want it to be. So I'm not sure what alternative name means, but we'll see. Okay, so now I have some practical examples. Like I said before here, I'm using the 32-bit CAPI command just because it's simpler and easier to type. You may need to use 64. Any place you see server name, it's the name of the server from the onconfig DB server name. IDS label is the name of the label from the onconfig SSL keystore label. The client P12 file, when created, will have 600 permissions. If you want other users to connect, you need to change it to at least 644. Okay, And both the client P12 and client STH file must be readable by whatever user is trying to use it. I probably should have added here that your key store that you create for the server certificate needs to be in the Informix SSL directory, and it needs to be only readable by the server owner. And I'll be happy to get into private servers if you want here, but generally that means Informix, and it needs to maintain its 600 permission so that other people can't get in and try and see your keys. Okay, so these are steps to create a self-signed certificate. Again, we're going to go to the Informix SSL directory. We're going to create the key database or the server key store there. Again, specifying the server name, the P12, the pass file you want, and we're going to tell GSKit to stash the password. Okay, and then to create a self-signed certificate, cert create. Again, you're specifying the key store that's used. This time you're saying that the password has been stashed. You're specifying the label that you're going to put in your onconfig file. You have to specify some sort of distinguished name. At least has to include a CN, but it can be a common name. But again, it can be anything you want. I think I have an example where I just used my login name for a common name. It doesn't have to be anything. And then expire, how many days you want until it expires. Again, I would point out on the common name, if you're asking a certificate authority, a commercial certificate authority to sign your certificate, you have to provide a common name and you have to prove that you own that domain. Okay. After you're done with creating the certificate, then you can extract it, and this will create a file. I called it here idslabel.cert. You can call it whatever you want. And this is the file then that you will go over to your client database. And when we get there, we will import this file, or sorry, add this file into the client key database. So now we're going to go to Informix or Etsy. We're going to create the client database or key store. The standard name is client.p12. However, there is a file that you can use in the Informix or Etsy directory called cont SSL CFG that will allow you to specify a different name if you don't like the name client.p12. And again, you have to remember to make this readable by all of your clients that have access to it. Okay, and then after we've created this key store, we're going to add the IDS label cert that we created in the step above where we extracted the server certificate. And this should be enough to allow you to create a client and a server that can communicate with each other using SSL. All you have to do is set up the SQL host file to say on SOC SSL and have the appropriate information in your onconfig file. Okay, so these are the simple steps: creating a self-signed certificate, putting it in the client file. And I might add that if your client is not local to your server machine, you can just copy the client P12 and copy the client STH file to the Informix on any Informix Etsy directory on any client machine. Okay. Okay. So if you want servers to communicate with each other using self-signed certificates for RSS, you need to have in your server key store the client certificate for the other server. Again, this is essentially using self-signed certificates, and we essentially end up with pairs of certificates that come from the server and the when you extract or when you extract it, you get the client side of that certificate. Okay, so you end up with all these pairs, and you have to distribute them to all of your certificates into the server key store. Now, not the client key store. For the servers to talk to each other, they only use the key stores that are in the SSL directory. Again, if you're going to have client connections here also, then you have to put the client P12 in the client directory. But basically, all you have to do is add the other server's certificate to your server key store to set up for RSS using SSL. Now, some of the more important stuff or interesting stuff, you can create your own certificate authority. Now, inside of your company, if you want to create certificates and you don't want to go to the expense or bother of commercial certificate authorities, you can create your own certificate authority. You can sign all of your own certificates. The only important part here is that you need to keep your root key database that's going to be used to sign all these certificates offline and protected, right? Because that's the secret key to signing all of the other certificates, and you need to keep this secret, right? And the other thing is, whenever you sign a certificate, and for what it's worth, this is also true for commercial certificate authorities, you have to give the root certificate or the chain of root certificates, intermediate certificates, whatever you have, so the client can verify any certificate that you sign, right? So the extracted, in this case, we're going to have a chain of only one root certificate, and you have to extract that root certificate and deliver it to whoever asked you to sign a certificate. So if you get a certificate request asking you to sign it, you have to not only return the signed certificate, but you have to return the extracted root certificate that you used to sign that certificate. Again, this is only the public part of the certificate. It's not the private part. Okay, so first step is you're going to create your root key database. And this is the stuff that you want to keep secret. So you create your root database, you stash the password, you create your root certificate, and notice the important part here is you say CA equals true, and then you extract the root certificate. Again, this only gets the public portion of the certificate out, and this is the part that you want to give to anyone who asks you to sign a certificate for them. Okay, so this is back now if you're a DBA and you're trying to set up an SSL connection using certificates that you're asking your certificate authority to sign. These are the steps you have to do. Again, the first step is to create the server key database in the Informix SSL directory. And then you create a certificate request. Okay, and you have to specify here the label that you would like, the domain name that you're going to be used for the certificate, and the file that is going to be the certificate request that you're going to send to the certificate authority that's going to sign your certificate. Okay. Note that this is the same no matter who is signing your certificate. This is the way you get the certificate request. And when they do the create certificate request, what we're doing here is actually creating the private key in the local key database. And what we'll get back when we get it signed is the signed public part. Okay, so now at your root KDB machine where you're going to sign the certificate for someone who requested it, you get the request file and you sign the certificate using the certificate sign command. Okay, you specify which certificate you're signing it with and the file name that you're going to create when you sign the certificate. You specify how long you want the certificate to last. Typically, we do a year. For what it's worth, there have been movements to try and get the amount of time the certificate is good for reduced. It used to be 5 years or so, and now there's a lot of places that won't accept certificates that are longer than 1 year. And then again, you send the signed certificate and the root certificate back to the requester. Okay, so back at the server key store, you add the root certificate to the server key store if you don't already have it, and you receive the signed certificate. Okay, and now your server key store is good to go. You should be able to validate your certificate at this point because you have the root certificate and verify that everything is okay. And for the client, right, after you've created the client key store, same thing we did before, you just have to add the root certificate that you got into the client key store. And note that once you've done this and you have a client key store, you can copy your client key store and stash file around anywhere that you're using a server certificate that got signed with this CA root certificate. Even if you have multiple servers that have their own certificates that are individually signed, you only need the root certificate. And you only, if you're doing it with a single root certificate, you only need one root certificate in your client key store. And this will work for any client, for any server that has a certificate that's signed by your CA. Okay. Are there any questions here? This is actually the end of the presentation, but I do have some stuff I'd like to show if we're not running out of time.
I have a very long question in the chat. Can you make the chat visible to you so I don't have to bore everybody by reading it out loud?
I do not know how to do that.
Lester, how good are you at explaining how to make the chat visible to him? Down the if you're looking at the same thing I'm looking at, down the bottom of the screen, you may or may not have a button named chat.
I'm not looking at the same thing you're looking at, I promise.
Yeah, I suspect not. I don't know if Lester might not be listening, he might not be hearing right now. Okay, I'll try to read it. It might be a little boring. Informix in CP4D allows to download CA-CRT and TLS.CRT for SSL connection in CP4D.
Yes.
Which file is required to fill SSL connection in CP4D? Or which steps should be done to get the right SSL certificate string?
So I am not an expert on setting up a CP4D instance, but having said that, you end up with a Informix server that looks just like a Informix server that was set up on a local machine. And I can only guess here, this is a question for Javier, but I can only guess that somehow when you're setting up your CP4D instance, you get to specify a certificate file that's put into the key store for that server. Okay? But I don't truly know the answer to that. But in some of the when you go to set up your server, there is a bunch of stuff that you have to specify. And I'm going to try to assume that the certificate information is part of this. Okay. Alternatively, as far as I know, CP4D requires SSL, and it may be that the files that they used, at least at the moment, are, shall we say, internally generated, and I'm not sure how you would specify a different one. But I know that CP4D requires SSL. I don't know if I've answered that, but I hope I have given it a shot.
And I have one more. Hey, Mark, in reference to alternate names. I ran into a situation where server.com was not considered secure because the certificate was generated for something that I can't read, .com, a different URL. Adding alternate name to the cert signing request allowed a single cert to work for both URL blah.com and server.com.
So I will just say this, as SSL currently works in the Informix server, that's why I said you can put anything in there. We do not verify, we have no way to verify, we have nothing to compare it against like you would in a browser, what you're trying to connect to versus what the certificate says. Okay. So we don't currently look at the common name in the certificate and verify that, again, you don't specify that you're trying to connect to xyz.com. So we have no way to verify that that's what you're actually looking at, right? I did figure out how to get the chat, so now I can see it. So.
Oh, good. Okay, so that was the one that Mark posed was the last one, I believe, in the chat.
Yes. So I mean, I've had questions about like wildcard certificates and stuff like that. The bottom line is we don't have anything to compare it against, so we don't care. We don't know. We don't care.
If you want to attempt the CP4D one, I can post. I'll just paste that into the bottom of the chat, so you should see it.
Well, I think someone answered that by saying that there's a thing in here that says that the CP4D setup allows you to. CP4D uses the certificate manager. So I will say that I see there's a question in here about connection manager. And I will say the connection manager works exactly the same way as the server does. There's a connection manager Informix SSL directory, a connection manager Etsy directory. You put the server side in the SSL directory. The name comes from the name in the connection manager config file, and you put the client side in the Informix client directory. Informix Etsy directory, sorry, Informix Etsy directory. Okay.
All right.
Okay, let me try it. I'm going to share a different window here if I can.
Sure.
I hope everybody can see this. So this is
small, but I think they can see it.
Okay. This is a key database that I made for. I have a server set up in Rome so that I can deal with some stuff that has to do with long distances. And my file, I don't know if you can see if I can highlight anything here, but my file is named DaveDS Rome P12. And basically what I've done here is, oh, by the way, Cappy is just my alias for the GSKit Cappy command. And basically what I've done here is list the certificates in this database. And you can see that I have a root certificate and I have my Roam certificate here in the database. And what I've done here, just for the purpose of illustration, is to use the GSKit can to dump the details of this root certificate just so that you can see what's in here. And you can see here that I just used the common name of my first name. It has a date that is, wow, I made this a few years ago. Not before October 2nd, 2017, and not after October 1st, 2027. So at the time I made this to last 10 years. And you can see that it dumps the public key here. It dumps the public key type. This fingerprint is just an SHA-1 hash of the file. There's an MD5 fingerprint and an SHA-1 and a SHA, whatever. And then basically you can see the extensions here. In this case, CA is true, so that the certificate can be used to sign other certificates. And again, this was quite old, so you can see that the signature algorithm here is an SHA-1 with RSA, which again is not considered valid these days for TLS 1.3. So I just wanted to show you that you can take a look at this stuff. For what it's worth, there's see if I have what I have here for a file. All right, I have the ASCII version of the file.
Before you finish this, Dave, and before people start to slip out, I just want to mention one little bit of housekeeping. Tomorrow's sessions, unlike the first 2 days, all begin at the top of the hour, not 10 after. So just notice that on your schedules. They all begin at the top of the hour, not 10 after. That's it. Go back, Dave.
Okay, so I just wanted to show you here that if I could get back to where I did it here. Okay, so this is the OpenSSL command that essentially does the same thing, although the certificate has already been extracted from my P12 file for the OpenSSL command. And basically you can see the same information here as you can see with the GSKit. Okay, so I just want to show you that all of our stuff, whether it's done with GSKit or OpenSSL, is all completely compatible. It doesn't matter what machine you do it on. It doesn't matter what tool you use to generate it. It's all the same. You can examine it with OpenSSL. You can examine it with GSKit, and it should all work just fine. Okay, if that makes any sense. So if you would rather generate your certificates using OpenSSL with a root, with some kind of commercial certificate authority, that will work just fine. Okay. So.
Anything else, folks?
I guess I'm done unless anyone's got any more questions.
And this session has been recorded, and the chat has been. I recorded the chat also on my own PC, so I could distribute it out to anyone who wants it. Oh, one more question. For client connections in CP4D, the TLS.CRT should be working for Informix clients. That's from Andreas.
Yeah, I think that was an answer to a question, not a question.
Yes. Yeah. I read it before I read it.
Yeah, no, that's fine. I'm looking at the chat now too. I can see it, so we're good.
Okay.
I finally figured out I had a pull-down menu at the top of my screen to do this stuff. So, all right. I guess if there are no more questions, thank you all for coming.
All right.
And if anyone has any questions, feel free to email me, and I will be happy to try and answer it any way I can.
And if you have general questions about the conference, it's conference@iiug.org. And if you lack an email for someone you want to email, we can get you that.
Yeah, for what it's worth, well, I mean, mine is david.desautels, my first name, last name, @hcl.com.
All right. Thanks,
Okay.
Dave.
All
Thanks,
right.
y'all.
Yep. Thank
We'll
you.
see you at 10 o'clock tomorrow morning.